1. The recording is started.
A very good evening to you, ladies and gentlemen. My name is Namadzavo Kone. I was with some of you last week, and we had started with our integration. I will just rephrase or revisit a few things that I started talking about at the beginning of the previous lesson. Number one is about the etiquette here in our class. We will not worry about you interjecting, but I will please request you to switch off your mics throughout the lesson. Only switch on the mic when you want to speak or ask a question. So there's not going to be anybody who will be watching you raising your hand. So you just unmute yourself and talk. Then I will keep quiet and will listen to your question or your comment, and then we'll continue with our lesson. Another important, very important thing is that you guys are very fortunate that you've got the information booklet that gives you all the formulas. You have got the formulas now that you are preparing for your assignment, and you will have your formula sheet when you do your assignment. You will have it as well during the exam. So what I'm trying to do in these lessons is try to assist you to show you how you can easily get a distinction in this subject, because every information that you need, you are having in your hands. Today, we're going to look at trigonometric integrals, and we agreed with Dr. Dlamini that we will fuse the two units because there are 2 units on integration. The first unit on integration is about integration of sine and cos, and then the second one is the integration of tan, cosec, and sec, and all those other trigonometric ratios. So the main reason why I decided to put them together is that you do not classify them as separate. When you see a trigonometric a function, you should be able to know how to tackle it in terms of how to do its integration, irrespective of whether it's sine and cos or it is the other 4 trigonometric ratios. So our first issue here will be again, you can see I have got integration rules number 2 and 3. Those 2 rules that we did previously are the key to all of integration. So whether it's integration using a trigonometric function, whether it will be the exponential function, whether it's hyperbolic functions, any form of integration is actually based on the 2 rules, rule number 2 and rule number 3. And now the rules that I'm talking about are the ones that I am showing now on the screen, which is this general rule of integration that I discussed in detail in the previous lesson. I'm not going to go back in terms of discussing this, but just for the sake of those maybe that have just joined us today, this integral, it's the integral of the function f of x to the power of n. If it was not f of x to the power of n, if it was x to the power of n, it does not need any red thing that you are seeing there for it to be integrated. If it is x to the power of n, it will just be x to the power of n plus 1 divided by n plus 1 plus c, and that's it. Now, if we want to integrate a function of x raised to an exponent, then that function of x just needs to be accompanied by its derivative, which I have put there in red, for it to behave like x to the power of n. And if you can check the right-hand side of this equation, you will realize that on the right-hand side, the function f of x, you just add 1 on the exponent and you divide by the result plus c, but the derivative falls away. It's just there to cushion the function of x for it to be able to be integrated. And this is happening for n not equals to 1. For any other n can be an element of real numbers except minus 1. It can be a fraction, it can be a decimal, it can be positive, it can be negative. It happens the same way. You add 1 and you divide by the result. But if you can check when n is equals to minus 1, if you follow the right-hand side, you will have minus 1 plus 1 on the exponent there, which is 0, and divided by minus 1 plus 1, which is a 0 at the bottom. So in a fraction, you cannot divide by a 0. That is why there is this restriction that says when n is equals to minus 1, you cannot do this integration the same way. And now, I am trying to move to the next one. Yeah, which is this one. So when n is equals to minus 1, it means that the function of x will be f of x to the power of minus 1, which is the same as 1 over the function of x itself. So it has to be also accompanied by its derivative, that red thing on top, for it to be able to be integrated, and then the integral will be ln of f of x plus c. So those two are key. You will see that we will be using them throughout this lesson, although we are talking about dealing with trigonometric functions. Our first example is an example from first year, so that we can be able to see the link between what we are doing in second year with what we did in the first year. So this one is the integral of 3 minus, I'm just admitting this student that is coming in now, so that it, yes, so that it does not block our view. So we have got an integral of 3 minus cot of 2x, all of this in brackets squared dx. So naturally, we will want to first remove the bracket by multiplying 3 minus cot 2x by itself twice. And there are people that even at this stage, they will think that you can come here and you say 3 squared minus cot squared 2x. You can't do that. You are supposed to multiply the way you multiply binomials. So after multiplying, you will get the integral of 9 minus 6 cot 2x plus cot squared 2x. And you will understand that the 9 is coming from 3 multiplied by 3. And then the minus 6 cos 2x is coming from 3 times minus cos 2x and minus cot 2x multiplied by 3. And you add the like terms together to get minus 6 cot 2x. And then the cot squared is found by multiplying cot 2x multiplied by cot 2x. And it gives us cot squared 2x. And you must bear in mind that cot squared 2x is not the same as cot of 2x squared. 2x squared is the angle itself. So if the square is on the 2x, it is different from what we have here. But what we have here is exactly the same as cot of 2x multiplied by cot of 2x. Then when you look at the things that are in brackets, you will realize that if you can now you go to your information booklet and you go to the integrals, you will find that the first integral is the integral of a constant, which can be done easily. And the second one, the second term, minus 6 cot 2x, if you check on the list of integrals, there is an integral there that you can directly from it find this integral. But when you go to the last one, the integral of cot squared 2x, you may find that there is no integral of cot squared. If there is, then you read it from the information booklet. But if it is not there, then there are what we call identities that you can try and manipulate to have an integral that is there in the list. So after finding that there is no integral of cot squared in the list of integrals, then you will realize that you go to your identities, and the identity that I just brought up there says cot squared x is equals to cosec squared x minus 1. So then if you go and check now in the list of integrals, you will find that there is an integral of cosec squared. Then which means that if you can now, before you start integrating, replace cot squared 2x by its equivalent, you get the integral of the following. The 8 that you see there is coming from that minus 1 that we have in the identity. So when we replace cot squared with cos squared x minus 1, then the minus 1 will be added to the like term, which is 9, and 9 minus 1 is 8. That is where you get this 8. The minus 6 cot 2x remains as it is. Now, in place of cot squared x, we will have now cosec squared 2x. And this one has got an integral. Now, we are going to now have a look at now the rules that we need for us to be able to do integration. And now the first one is rule number 9. Rule number 9 has to do with the integral of cot 2x. So if you go now to that information booklet and check rule number 9, it will give you how to do the integral of cot 2x. And when you go to rule number 13, it will give you how to find the integral of cosec squared 2x. Now, what I just did now is just to separate each and every term so that it can have its own integral. The first one, which is our integral of 8 dx, it's separate there. So 8 can either be sitting there or you can move it outside so that you can have just an integral of 1 dx, because you all know that 1 is the same as x to the power of 0. So that when you do your integration, you add onto the 0 and you divide by the result. Now with the second one, I want to explain now why we have split that 6 into now the minus 3 and the 2. If you go to rule number 9, you will realize that rule number 9 says that if you want to find the integral of cot of f of x, that cot of f of x must be accompanied by the derivative of f of x. Now, in this case, our f of x is 2x, and the derivative of 2x is 2. That is why I've put that 2 there in red, because in the next step, it will disappear. It will not be there, but then cot 2x will be able to be integrated. Then what I just did, I just split the 6 into 3 multiplied by 2 because I needed the 2 for that. Or otherwise, I can explain it the same way I was explaining in the previous lesson, that we are taking 6 out and we need the derivative of 2x, which is 2. Then we put a 2 inside, and outside we multiply by a half to compensate for this 2. Then this minus 6 that is outside multiplied by a half gives you this minus 3 that you see here. So then that is how we got this one. Now from this, now you can read from rule number 9 how to find the integral. Is straightforward. Then we go to this other one. It is also now rule number 13. Also rule number 13 goes like, when you have got the integral of cosec squared f of x, it has to be accompanied by the derivative of f of x. In this case, it's still the value 2. And now that value 2 is the one that you see in red. And then the half that is outside is there to compensate for the 2 that we needed to be there, which was not there in the previous step, so that we don't change the integrals into something new that we didn't have. Then from there, we go and read and do the first one, which will be your 8x. And then the rest of the other integrals, you read them from the information booklet, and you get rule number 9 and rule number 13, and you get that the integrals are as follows. 8 of 8x from 8x to the power 0, 0 plus 1 divided by the result will give you the 8x. Then minus 3, the 3 which was there outside, it just comes down as it is. And according to the rule number 9, the integral of cot 2x is ln of sine of 2x. And now the reason why now the sign changed on the third term from plus to a minus is because if you can check rule number 13, the integral of cosec squared of f of x is minus hot f of x. So that is where this negative sign is coming from. And after you finish all the integrations, you're going to put a plus c at the end. And that gives us the answer to this question. Now we move to the next question. Now the next question is integral of sine of x multiplied by cos of x dx. Now, if you can check in your list there, you will not find any integral of a product of sine and cos. But now, as I have said at the beginning, you have to be very sharp with your derivatives. Now, if you remember your derivatives, the derivative of cos is negative sine of x. So if now you go to that rule number 2 and rule number 3, and now you look at that rule, it says that if you have got a function of x, accompanied by its derivative. If you've got a function of x accompanied by its derivative, then it means that you can do the integration if your function of x is raised to the power of n. Now, in our case, if you can take f of x as cos of x, then sine of x minus sine of x should be your derivative. Or the other way around, if you can take f of x as sine x, the derivative of sine x is cos x, which means that you can take f of x as sine x and cos x can act as a derivative. So I will show you the different variations of the way in which we can solve this particular question. The last option here would be to use the rules for compound angles. If you remember, sine of 2x is equals to 2 sine x cos x. So which means that if we can play around with this one and introduce a 2, we can rewrite this as sine of 2x and have got a single integral of a single trigonometric function sine of x. So let's start with the one where we will take f of x as sine of x, because now the derivative of sine of x is cos x. Here, we still are talking about trigonometric functions, but now we are going to use rule number 2 to do this integration, although what we see in the integral is trigonometric functions. Now, our knowledge of derivatives help us to be able to think along these lines, that now the cos of x that I'm writing now in red is the derivative of sine of x. Then which means that this sine of x is on its own having a power of 1. So which means that when we want to do the integral of that, we will just now come and say, we will take the sine of x, which is raised to the power 1. We take 1 and add another 1, and we will get a result of power 2 and divide by the result. So then that is why you see sine squared of x there. And the half that you see there is from dividing sine squared x by 2. So I just factored the half outside. And then we just add the c, and we are done. That's how easy this question is. But a person who does not understand number 1, rule number 2, who does not understand number 2, rule the derivatives themselves, will not be able to answer this question. Because in your eyes, you will see two trigonometric ratios. You will go to the list of integrals there. You will not find any one of those rules giving you a straight answer. Then it means that you are supposed to be able to manipulate this to look like a rule that is there. Now, the rule that we have manipulated to here by writing this cos in red is rule number 2, where we have got our function of x, which is sine x, accompanied by its derivative cos of x. And then, hence, we get this one. Now, as I have said, Tabani Clifford, please just unmute yourself and speak.
Good evening, sir.
A very good evening to you, sir.
Yes, somebody last week raised a point about you, maybe if you can write while explaining. So, because I'm trying to follow you while you're explaining, but now if you are not writing, like most of the time, it's only you who is talking,
Yeah,
and I find it difficult.
I'm allowing you to talk so that we can talk together. So, okay, let me explain why I'm not writing. I am using a laptop that do not have a facility to write on the screen. So the laptop that I have is my personal laptop. The laptop that I have does not have those kind of facilities. Maybe Dr. Jamini will be able to write as she speaks, because her laptop has got the facility of a pen. So mine does not have. I'm so sorry about that. That is why I've prepared everything written. But when I'm saying that we are going to do the other examples, it means that I've prepared them, you will see them. But then I'm allowing you to interject so that I can be able to explain where you don't understand, like what you are doing now. So what is it that you would have liked me to write?
I mean, like I can understand all the examples that you are showing, but
Yes.
I would prefer for me if you engage us also like ask what could be the next step in this question here, something like
Oh,
that.
perfect. Then
Yeah,
now if that is the case, then I can do that. That I will do. It's fine. That we will be able to do so that I don't show you the steps. I let you do it. So like for example, I could have done this. That is what you are suggesting. Say now we are here. We have identified our f of x is sine of x and our derivative is cos of x. Now, guys, can you please let me know what the integral of this will be? And then somebody says,
yes.
and then we can check. Okay, that is the way you want us to go to continue. It's fine. It's just that it will take a little bit more time than, but I have got a few examples today, so I don't think it will affect our 2 hours. So I will do it that way, my friend. Thank you so much for the suggestion.
All right, so thanks.
Perfect. So, but then I've already shown you this one, so we'll go to the next one. Now, in the next one, now you will see a lot of negatives now. If we take our cos of x as our f of x, according to the derivatives, the derivative of cos of x is minus sine x. Now, because we want that derivative to be seen as minus sine x in red that you can see there, we need to compensate it by a negative outside. It's like multiplying this whole expression by -1 times -1, because we know -1 times -1 is equals to +1. Now, then we take the other -1 outside, which is the negative that you see outside the integral sign, and the negative now that you see accompanying sine x inside there. Now, can we now go to the next step of now using rule number 2 to do the integration, which means that our red is our derivative and our black is our f of x. Now, can you please, someone can please let me know what the next step will be after integrating?
Can you repeat the question, sir?
The question is, we have set up our integral so that we can be able to identify our f of x, which is cos x in this case, the one in black, and the derivative thereof, which is what is in bracket there in red, which is minus sine x. Minus sine x is the derivative of cos x. So my question is, now what will be the next step after we now apply the integral using rule number 2?
I
Anyone?
think it's gonna be the one where we add n plus 1 on top there and then divide by n plus 1 also on the bottom.
Please do that on this one and give us the answer like we have on the left side.
Which is gonna be minus half cos squared x plus c.
100%, which is that one. And that's how easy these things are. Thank you so much. Now we go to that other possibility that I've explained about compound rules. So the only difference, the only problem we have now is that we know that the compound rule that contains sine x cos x has got a 2 that is accompanying these things for us to be able to equate it to sine 2x. And that 2 is not there. It's not given there. So we have to bring it. We have to bring that 2 so that now we have that 2 inside and we compensate it by the half that is outside. So that if we can multiply that half inside, we get back to the original. So which means that the original is exactly the same as what we have there. It's just that what we have there now gives us an ability for us to be able to do that reverse of compound rule of sine of 2x. And that's now rule on the left hand side. We have applied the identity that says 2 sine x cos x is equals to sine of 2x. But then also, for us to, when you go to your list of integrals, for us to be able to integrate, I'm sorry I didn't do my 2 in red here this time, But this 2 that you see that is in there, that was compensated by a half. That half multiplied the original half that was there to give us this 1/4 that you see there. So that 2 is required there, because if you go to the rule that is about the integral of sine, I think it is either rule number 8 or rule number 10. I'm not sure, but you can check that. So that rule says if you want to integrate sine of 2x, I'm sorry, sine of f of x, then it must be accompanied by the derivative of f of x. And in this case, our f of x is 2x, and its derivative is 2 that you see outside there before sine. Now, I want you guys to go and look at that list of integrals and give me the integral of 2 sine 2x using that list of integrals that you have there. And what will be the next, the answer, the final answer there?
So would it be 1/4 negative cos of 2x?
Which can be rewritten properly as minus 1/4 cos 2x plus c. And I think you are right, which is this that we see there. And that's how you do this integral. So these are 3 different ways of doing the same integral. Now, some people may say, sir, now, why are these answers looking different? How can we show that all these 3 answers are correct? Anyone? These 3 answers are not equal, but they are all correct, 3 different correct answers of the same integral. How can we prove that indeed these 3 answers are correct? Anyone?
If we were to show them on a graph, maybe?
Graph? I don't even know how to draw the graph of sine squared x. But I know it could be drawn. I only know how to draw the graph of sine x. If we draw the graphs, we will see the graphs of sine squared x, the graph of cos squared x, and the graph of 1/4 cos 2x. They will not look the same. The graphs will look different. But there's a way in which we can prove that indeed these 3 answers are correct answers.
Yes,
And
but
one person at a time?
we derive, sir.
Okay, yes, because what we were doing here, Tandeka, you are raising up your hand before we go on. Tandeka?
I was saying you have to derive.
Oh, okay, the same as the previous speaker. So which are you are both correct, because what we are doing here is integrating, which is the reverse of differentiation. So if we find the derivative of each one of these 3, we should get back to the answers that we have there. So I will want to give you that as a task. Unlike WWE SmackDown, this is mathematics, so you can do this at home. So please go and find the derivatives of these 3 and tell me maybe in the next lesson if you didn't find the answer as sine x cos x. Right. Now we have got a different scenario. Now this scenario, it's saying we've got an integral of sine of 5 theta multiplied by sine of theta d theta. And you go to the list of integrals, you will never find anything that has got these 2 names. I think the only 2 names that you will find in the list of integral is when you have got the integral of sec theta tan theta and cosec theta cot theta. I think that is an integral that has got 2 names. Those are the only 2. But to have it with 2 signs, which is sine of one angle and sine of another angle, that doesn't happen. So I would like now from you guys, how will we be able to attack this question? Any suggestions? We've got sine of different angles. It's sine of 5 theta, and it's not the same as sine theta, so the angles are not the same. If maybe it was sine theta and multiply by sine theta, we'll just make it sine squared theta and see about our maybe identities and so on. But here we've got two different angles. Any suggestions? Do you remember? Oh, okay. Somebody wants to talk.
No, I was just wondering if you could use the identity sine x sine y is equal to half cos x minus y minus cos x plus y, and then solve separate integrals for cos x minus y.
Can you please repeat that identity that you just mentioned?
Sine x and sine x and sine y is equal to a half cos x minus y minus cos x plus y.
So is that identity in the list of identities in trigonometry? Is it listed there amongst the list? Hello?
Yes, sir, on page 14.
So if it is there, then you just take it straight. I didn't even check. I didn't even go to the integral. So it means it is listed. So what I did, I actually derived that identity that he's talking about. Because that identity that he's talking about, thank you so much. And I mean, you are absolutely spot on there. So if it is there, then it means that this question is very simple. You just go to the trigonometric identities and you use that which you just mentioned. But I had to derive it, and this is how I did it. So it is what I'm showing you here. It is not necessary if that identity is there listed. So you just go there and use the listed example. So in place of x is your 5 theta. In place of y is your theta. And then you use the identity and then you get different integrals as he explained. And voila, you are done. So this is how I did it, but it is a long way. So the shortest way is what our colleague just mentioned right now. So what if you look at these identities, so I think that one that he just mentioned are amongst these ones. I don't know why I didn't see it. But so this is what I did. I looked at these four expansions of sine of a plus b, sine of a minus b, cos of a plus b, and cos of a minus b. And I look at those that will have sine repeating, which means it is the last two. If you can check here, sine here is repeating and sine there is repeating. And for me to create a situation that we have here, which is sine 5 theta and sine theta, we can either, in fact, we can only subtract these two equations. Either we'll say the last equation minus this one, or the one on top minus this one. But now, because we want to avoid negatives, let's go and say the bottom equation minus equation number 3 there. So that we will have sine A sine B minus becomes plus sine A sine B. So on the right hand side, we will have 2 sine A sine B. And this is how I did that. So the right side, as you can see, is 2 sine A sine B. It's from the last equation minus the equation before it. And the left hand side will be cos of A minus B minus cos of A plus B. And this cos A, cos B will subtract each other out. So this one and this one are gone because we are saying this equation minus this one to give us this, which is on the left, cos A minus B minus cos A plus B. And on the right side, this will subtract this one out, it's gone. And then this minus this, it becomes a plus, and we get 2 of those. So I think if you can now multiply by half both sides, you get the equation that he just mentioned right now. And thank you so much for that. So guys, you don't have to do what I just did here. The identity is stipulated. Can you please tell me what number is that identity on the list?
It's on page 14, so as a list of trigonometric identities of unit 2.
Of the study guide number 2.
Yeah, correct.
Perfect. So that you go there straight and you copy this, and then you get that. From that identity, you get straight to what we have here. So your x is your 5 theta, your y is your theta. And then after you get this, then It's just a matter of doing arithmetic. 5 theta minus theta gives you 4 theta. On the other one, 5 theta plus theta gives you 6 theta. And then now you have got your individual integrals. And now the thing that I was talking about from the beginning, the things that you see in red are derivatives of what is inside. Derivative of cos of 4 theta itself, it's 4, it's outside. The derivative of 6 theta is outside. Now the reason why we have got a 1/8 there, it is that half that we have there outside in the second step, multiplied by 1/4. That is compensating for this red value that is there. Same applies. Our 1/2 that will come in there, and it will get a 1/6 that is compensating the red 6 that you see there. Then from there straight to I think it is rule number 9, and then you get this integral straight from there, and then the answer will be that one. So this one, I've made it look more difficult than it actually is, because that I didn't check that list of integrals on trigonometry, which will give you straightforward answer. But that is how you do it. Now we have a cos raised to the power of 5 of x dx. Now when you go to the list of integrals, the integral of cos is there, but there is no integral of cos raised to n exponent. Now, and this exponent is huge, is 5. So now, can I have maybe suggestions from you guys? How do we do this now? We've got cos power of 5. Any suggestions on how we can attack this one? Anyone? Okay. In the absence of suggestions, what we know is that we can deal with square identities. Now, the power of 5 does not give us that option of dealing with square identities, because 5 is an odd number. So the suggestion that I can make here is, how about if we separate this power of 5 into cos power 4 times cos, as it is. So it means it will be cos power 4x and cos of x. And that cos power 4 is the same as cos of x raised to the power 4, which is the same as cos squared x squared, multiplied by a single cos x dx. So I hope you agree with me that these two things are equal. This cos squared x squared gives us cos to the power 4x. Multiplied by a single cos x, it gives back our cos to the power of 5 of x. So the reason why we did this is because what we know is we have got squared identities. So that those ones we can work with. Now, if you now know your derivatives, you will know that for you to have cos x as a derivative, in this bracket, you will need to see sine of x. And that is where the identity comes into play for us to replace this bracket with something that contains sine. And that, according to the squared identities, is what we have on the screen there. And then from here, it's just a matter of now taking the 1 minus sine squared and you square it. Please do not get into a trap when you see something like this and you think that this is 1 squared minus sine to the power of 4x. It is not. You still need to multiply it like you do multiply binomials. And when you do that, you will eventually get 1 minus 2 sine squared x plus sine to the power of 4x. And now you can now take 3 separate integrals because we've got 3 terms inside. So each one of the integrals will be having cos x dx. Each one of the 3 must have that cos x dx. And then we eventually have the integral of cos x dx, which is found by multiplying that by 1. And now the second term will be minus 2. I just factored out the minus 2. And we have sine squared x multiplied by cos x dx plus sine to the power 4x cos x dx. And I've written the cos x in red in both the 2 last terms, because if you take f of x as sine x according to rule number 2, so our f of x is sine x and it is squared. On the other one, our f of x is still sine x and it is raised to the power of 4. The derivative of that sine x is that cos x that you see in red. Now, guys, can you please do the final step for me? What will be the integral?
It's going to be equals to sine x minus 2/3 sine cubed x plus sine to the power 5/5 plus c.
100%. That is just the rule number 2. On the first integral, you go to rule number 9. I think if it's not 9, it's 8. And then you read it directly from that rule and it will give you sine of x. Remember, the integral of cos is positive sine, but the integral of sine is minus cos. Because of you remember, we are reversing the derivatives. And what he just mentioned about the other 2 is absolutely spot on. I think for cos is rule number 7. And then rule number 2 will work for the other 2 integrals. And as he has explained, 100%, that's the final answer. So now, what happens if that power was even? Because now we've got cos to the power of 5x, and we were able to separate the cos x, and then the other one now was even. What about if we were given that as an even number? Like we have here in this case, we have sine to the power of 4x dx. Now, if we do the same thing that we did before of separating these two, separating one sine x, the other one will have a power of 3, and squared identities will not work in that case. Now, any suggestions? What is it that we can do? Because now the power is even and we've got only one name and there's no integral of sine to the power of nx dx on the list. Any suggestions?
So could you do 1 minus cos squared x squared?
So we are reducing it to now, so which means that that suggestion says we must take sine squared x squared and replace that sine squared by 1 minus cos squared. Then let's see if that is what I did in the next step. Oh, I did that. And now, instead of replacing with 1 minus cos squared, because if I will do that, then that square outside will still be there. So instead of going to that step of replacing it by 1 minus cos squared, you go back to your identities, those trig identities. I think they are coming in handy. The main idea is to remove the powers here. The main idea is to remove the powers. Now, if you look at what is inside the bracket, we can be able to rewrite it without an exponent by using the identity that I've just shown you there. I don't know the position of this identity in your list there, but it is there. It is just the reverse of the identity for cos 2a. Because if you remember, cos 2a is equals to 1 minus 2 sine squared A. And if you can make sine squared A the subject of the formula, you get what we have on the right-hand side of the screen. So that is how we should do this one. Now, after doing this, we still have got a problem because there is that power of 2, which means that we need to raise whatever is in this bracket to the power of 2. And when we do that, as I have said before, never forget that the half squared will be 1 over 4, but the bracket 1 minus cos 2x must be multiplied like we do with binomials. Never, ever come and say it's 1 squared minus cos squared 2x, like what a lot of people do, and they lose marks unnecessarily. So then now, after we square that bracket, that is what we have. Now, the only problem that we have in this integral is that cos squared, because it still has a square, and we can use the same kind of an identity to remove the cos squared, so that we don't have a power or any exponent on the trigonometric functions, because only cosec and sec squared are the ones that have got integrals. The rest, only the integrals are of the one that has got power 1 in terms of trigonometric integrals. Now, the identity that we have now on the right hand side will assist us in that regard. So in place of cos squared, we are going to replace it with what is on the right hand side. And then when we do that, we eventually have our integrals. Now I have actually separated them. The first one is the integral of 1 dx, which is this one and the 1 over 4. The second one is the minus 1 over 4 and the 2. The minus 1 over 4 is becoming negative because of the negative that is there in the middle term. And we have got the integrals of 2 cos x dx. And then the 1 over 4 now multiplied by now the integral of the replacement of cos squared 2x. Now, if you can check here very carefully, our A is 2x. Our A here is 2x. Now, when it becomes 2a, ours now will become twice the 2x, which becomes 4x. You must be very careful about these kind of things, because already here we had a 2x, but here is an a. So in the place of a is 2x. When it doubles, it becomes 2a. So when 2x doubles, becomes 4x. Now we have got a scenario that we are looking for that has got cos with no exponents at all, which means that we just have to apply that rule. I think it was rule number 7 in the previous question for us to do this integral. And exactly it was rule number 7. So we rewrite now our integral exactly in the way in which rule number 7 says. It says, for you to integrate cos of a function f of x, that cos of f of x must be accompanied by the derivative of f of x. In this middle term, it's a 2. In the last term, it's a 4. And then from here, you can integrate. Can you please kindly do the integral and give me the final answer after doing the integral of each and every one of those 10? Anyone with a final answer?
I can give it a go, sir.
Yeah, please do.
I've got 3x over 8 minus 1 over 4 sine 2x plus sine 4x over 32 plus c.
100%. Because the 3 over 8 is just a constant integral of 1 dx. 1 is x to the power 0. 0 plus 1 divided by the result, it gives you an x. That is where he got our 3x over 8. And then this other one, the middle one, minus 1 over 4 is outside. So we look at the integral from rule number 7. It says that the integral is sine of 2x, then sine of 2x all over 4, which is the 1 over 4 that was there. And the last one, exactly the same way, sine of 4x now over 32 because of the 1 over 32 that is there. And that's absolutely correct.
So may I just ask, where did the 3 over 8 come from? I might have missed that.
Right. Thank you so much. Now, if you remember, we had this 1 over 4, 1 times 1 dx. Now here in this, when we replaced this one by that, it gives us that 1 over 4 that was there, which is this one, multiplied by this half that is coming from the trigonometric identity there, and it gives us 1 over 8. That 1 over 8 multiplies this 1 dx, and we get 1 over 8 dx. Now, 1 over 8 plus 1 over 4, what do we get? I think that is where the 1 over 8 is coming from. Because 1 over 4 is the same as 2 over 8, and then 1 over 8 plus 2 over 8 is 3 over 8. So that is where this one is coming from, when we have added this one and this one. Happy?
Okay, got you. Thank you.
Perfect. Right, now it becomes even messier. We have got now 2 trigonometric ratios that are not the same, and they have got powers. This is now a smallanyana nightmare, which we need to find a way of solving it. Now we've got sine cubed of x and cos squared of x. Anyone with a suggestion of how we can attack this one?
The first step for me is it will be to break down the sine cubed x, which will be sine squared x multiplied by sine x multiplied by cos squared x. That will be my first step.
Your first step is ideal. I agree with you, because if you break down the one that is odd, the power that is odd, you will have it separated, and then you have got a power that is even. Now, with powers that are even, even if it was, even if this question was sine to the power of 5x and then cos squared x, you zoom into the one that has got an odd power and break it up, so that you can be able to rewrite the others in terms of cos squared and sine squared, because you know that there are identities involved there. So brilliant suggestion. And that is exactly what is happening here in the next step. Now, we just did what he explained there. We took out one sine of x and we put it outside there, and we are remaining now with sine squared x cos squared x. Now, we need to come up with a decision. Now, this sine x that is alone is a derivative of something. What
Negative
is
cos of x.
the sine of x? This one here is a derivative of what?
Negative cos x.
Cos x.
It is the derivative of minus cos x, isn't it? So in fact, we can be able to, let me put it this way, we can be able to associate this sine x with a derivative of cos x. Now, because of that reason, now we need to make a decision as to now what we do with these two values that are here. Do we want these values to only contain sine or to only contain cos, if this is a derivative of a cos?
What, sir?
To contain cos.
To contain cos, which we will be able to identify as our f of x. So that is how you have to decide here now, because this can be associated with a derivative of cos. If we can see only cos here, our job is halfway done. So that is why we are bound in this particular example to change only this one into cos. Because this sign of x must be connected to the derivative of our f of x. If you agree with me, then that is why our next step looks like this. And from here, I think you guys can be able to continue and get to the answer. Can I please not show you the next step and you continue from here and give me the next step before you do the integrals? Give me the step, the step that will prepare you for integration. What will it look like?
To open the brackets
Yeah, and
by
give me the
saying
result.
what
Yes.
that 1 times cos squared sine x is going to give us cos squared x sine x. Then also open minus cos squared
With
x
dx.
times.
So never forget
Okay,
to mention dx all the time.
let me give you the whole answer. When
Yes.
you open the brackets, it's going to be integral of cos squared x times sine x minus cos squared to the power 4 times sine x all dx.
Oh, you have factored out the dx. It's fine. But I thought maybe you would do the integrals one at a time. But if that is what you have said there is absolutely correct. If you factor in only cos squared x and x inside the bracket, you get that. But what I wanted you to say was something like this. Although here we have got all these negatives. But now the negatives are coming. Somebody said before we even changed this, that the derivative of cos is minus sine x. So that is where now we have all these negative signs. So after your explanation about from this step to the next step, then when we separate the two integrals, we are supposed to separate them in such a manner that we have we separate them in such a manner that we have to be able to see which are our derivatives, which are our f of x. And that, for us, we do it by finding that the derivative is minus sine x, which you see in red here. That is why we have a negative outside to compensate for this negative sign that we have to introduce, because the derivative of cos is minus sine. And then this negative which was there actually gets inside here and sits with sine x to have this red thing that you see there. And then that is why now here you have a plus sign. This plus sign is coming because this negative sign moved in here to create our derivative of cos to sit as minus sine of x. And from here it's just a matter of rule number 2. Can you please apply rule number 2 and give us the final answer?
It is negative 1 over 3 cos cubed x plus 1 over 5 cos to the power 5 x plus c.
100%. I would think that now we are on the groove. We are able to see exactly what is going on. We just rule again. You can see how often we are using rule number 2. It is almost everywhere. So that is why I said at the first lesson that that rule is the key to all integration. Everywhere it will pop in. It will pop in. You will see as we continue with these lessons that rule number 2 is always there every time. Thank you so much for the answer, and it's exactly correct as you said. And now we look at this one. I think this one has feathers as well and horns. So it's the integral of tan power 6x sec to the power of 4x dx. Now, this now brings us back to that statement that I mentioned at the beginning. For you to be able to do integration, you must have mastered your derivatives. Now, here, there are two possibilities for derivatives. There's a derivative of sec x. What is the derivative of sec x?
Sec x tan x.
Is sec
Tan-
x tan x. So now, because of that fact, if we try and remove from tan power 6, 1 tan x, and from sec to the power 4x, 1 sec x, for us to have that as a derivative, will we be able to work with what is remaining? If we take away 1 tan x and take away 1 sec x, so that we have tan x sec x as our derivative on the side, whatever we remain with, will we be able to work with that? Yes or no?
Yes, I think so, sir.
What we will be left with is the following. We will be left with tan 5x and sec 3x, sec power 3x. And after we separate tan x and sec x, we will be left with tan power 5x and tan power sec power 3x. Will we be able to have identities that will assist us in working with those?
I
Do you
don't
still
believe so.
think? Do you still? I don't think so. I also don't think so, because our powers that we work with, which has got identities, are powers of 2, isn't it?
Correct.
So which means that that option of trying to have our derivative as tan x sec x in this case immediately fails. So we've got only one option of a derivative. Is there a derivative of anything that is tan x as it is without sec? Do we have a derivative that maybe gives us a derivative of something and it gives us tan x, or it gives us sec x?
So the derivative of tan is sec squared x.
That is the only one that we have in the derivatives. It's sec squared x. Now, it means that that is the cue for us now to come and sorry about that. That is the cue for us to come and attack this question. So which means that first step here will be to separate a sec squared, and we keep it aside as our potential derivative. Then we see what we are left with. And that is because of what you just mentioned there, that the derivative of tan x is equal to sec squared x. Now, because of that, then we are going to leave our tan to the power of 6x as it is, and we split the sec to the power of 4 in 2 parts. One part is sec squared x, another part is sec squared x. And that sec squared x, that one sec squared x, we will keep it as a derivative. Now, because we have already seen this derivative that is here, so for us to have this as a derivative, it has to be a derivative of tan, which means that then we must try and make this sec squared disappear. Only tan must be seen on this side. So now we go to our squared identities and find an identity that will replace this sec squared x with a tan. And the identity looks like that. Then we use this identity and we put it in there. And now we get something that looks like this. And from there, then we remove the brackets. And now it gives us this in 2 integrals. The first integral is when we multiply tan 6 with the 1 and sec squared x dx to give us the first integral. The second integral is when we multiply tan power 6 x with tan squared. It gives us tan power 8 x, and with the sec squared, and as we just have mentioned, we know that sec squared is the derivative of tan x. So which means in this case, our f of x is tan x is raised to the power of n, which is 6 on the first term, n, which is 8 in the second term, and normal integration occurs of rule number 2.
2.
Yes, that rule number 2 is so powerful. So please remember that rule number 2, just make it your best friend from now going forward, because it will give you the best results all the time. And now it is just straightforward integration. I think this one is easy up when we are here. You just add 1 to the exponent and divide by the result. And you add a C and voila. Now I think you will be able to tell me what we are supposed to take out when we have got a situation like this and the powers are odd.
Sorry to interrupt you, but can you please go back to that question that we previously did?
This one?
Can you please explain how we came about the final answer?
Oh, the final answer. So I thought we have done it so many times that you could see. So that's why I write through. Sorry about that part. I should have explained that. Now, our tan of x, if you go look at rule number 2. Rule number 2 says you must have an f of x, which is raised to an exponent n. Our f of x in this case of the first term is tan x, and our exponent n is power 6, is 6.
Yes.
And the derivative of tan x is sec squared, which is in red. The same applies to the second integral. Our f of x is tan of x raised to the power n, which is 8 in this case. And the derivative of tan x is the one in red, which is sec squared. Now, rule number 2 says when you integrate, the derivative itself falls away and it allows f of x to behave like an x. So which means tan x is now behaving like an x. So the exponent 6, you add 1 and divide by the result. So then you get tan power 7 of x divided by 7 for the first one. For the second one, do the same. On the 8, you add 1 and divide by the result. So it will be tan power 9 divided by 9. So that is where you are getting the 1/7. I just factored out the numbers, 1/7, so that I don't write it as tan to the power 7/7. It's the same thing.
Yes, yeah.
Does it make sense?
Yes, it does. Thank you.
Perfect. You're welcome. 100%. And please do it like that. So do not allow me to move to the next step when you didn't understand the previous one. Never allow that to happen, please. Just do that. Just interject and say, hey, how did we go from here to there? So that we go together as a team. Now, I was saying here, the powers are odd. Now, what would be an ideal derivative here to be taken out? Anyone?
Would it be sec squared again because it's the derivative of tan?
So say we do what you just suggested. So it means that on the sec power 5, we will factor out the sec squared. What we will remain with is a sec with power 3. Is there anything we'll be able to do with it?
No, we must make it sec squared sec.
Yeah, there's another voice. Can you come up with your suggestion?
I believe sec tan.
We're gonna be left with, if we take 1 tan, we'll be left with tan squared, which is an identity. I think we must use the tan side.
But then if we take only 1 tan out and we are left with tan squared, then we still have a problem with this sec power 5. Because if we change the tan squared into sec, we will have a sec to whatever power, but the derivative of sec is not only tan. That is where the problem will be.
Oh, okay, I see. It's
You see it, ne?
Yes.
So there is another suggestion that somebody has mentioned in the previous question, which it was not applicable there because the powers were even. That is the one that we need here. If you remember, what was that suggestion?
Derivative of sec f of x. sec theta.
What is the derivative of sec theta?
Sec theta tan theta.
Is sec theta
Sec
tan
theta tan
theta?
theta.
Absolutely. So now this is where you are going to take one from each here. So from tan cube, you'll take one tan. From sec power 5, you take one sec and you put them aside. That is your derivative of sec theta, which means that now you will want to change everything that is left in terms of sec to go from tan to sec. So which means this is from this fact that the derivative of sec theta is tan theta sec theta. You will come here and now you remove one tan, one sec, and you put them aside so that they represent the derivative of sec theta. Now your fight now is to try and make everything on this side to have sec theta only. And that is possible because there's an identity that can replace this, and then you will have this as the derivative, and everything is on track. So the integral, the identity is this one, and then you do that. And from here, you can be able to now put tan theta sec theta separate as a derivative and be able to do this integration. Can you please continue up until the end and give me the final answer? This goes to show that as long as you are very sharp with your derivatives integration and you are sharp with your derivatives and you are also sharp with the rule number 2 of integration, then the rest of integration is just a piece of cake. Please go on until the final answer and let us know what that answer is.
I believe, sir, it's gonna be integral of sec to the power 6 theta times tan theta sec theta minus integral of sec to the power 4 theta times tan theta times sec theta.
Yes.
Theta.
Yeah, I think you are talking about this step now. So I wanted you
Yes,
to
sir.
go on and get to the final one. Now this, you are preparing your
Fine.
integration now.
The final
There's
answer
another-
is sec to the power 7 theta over 7 minus sec to the power 5 theta over 5 plus c.
100%. Because now, remember, the red parts are just there to make sec theta behave like a variable. And then that is the answer. And that is rule number 2. Rule number 2 is ruling. There you go. That's how easy these things are. But they are only easy when you are very on point with your derivatives first. Because those are the ones that will be able to make you decide what is it that you are supposed to factor out there. So which means, in short, we can summarize that when both powers are even, your derivative will be sec squared. And this same applies if it was cot and cosec. The same way of doing these things. If it was cot and cosec, it's just that with that one, there are negative signs involved. So the examples that will include cot sec and cot. If the powers are both even, then cosec squared is the derivative. If the powers are odd, then you factor out one of each so that the derivative will be the derivative of cosec, which is a cot times cosec. That's the way to go. And from there, it's rule number 2. And amazingly, we are done for the day. And we still have got a lot of time. If you've got any other comments or questions. So this takes us through Unit 2 and Unit 3. And then next week, we'll go to unit number 4. Any questions, comments? Nothing.
Yes,
So-
I do have a comment.
Yes, sir.
Yeah, like I'd like to get your details if like I'm going through any of these units that we are doing, then maybe if I encounter a problem. Like I did on unit 1, did encounter a problem when I was doing post-test 1. I don't know if we
okay.
can check that or
Unit 1
I need some clarity
on unit
Yes.
1.
on post-test. Yes.
So you have got, do you have a question that you
Yes,
can
I
maybe?
do, sir.
So let's do this. Let me create an empty slide and we try and do that question. Since we still have time, I think we can try that. Let me go home and add a slide, and you give us a question and we try and do it. Hopefully we will be able to do that. Yes. Let me just go to my math type thingy. I wish I could do what Dr. Dlamini does, to be able to write on the screen. What was the integral?
Let me have a look. But it was on unit 1 post-test. Let me
To
just have a
pause
look.
a little, Mr. Namadzabo, can't you
Yes,
use
you can call me Nama or Mr. Kone. I don't mind. You can call me
Okay.
Nama or yeah. So you don't chew your tongue with my name. Yes, ma'am.
Yeah, but we need to learn Namadzabo.
Oh, Nama, yeah, perfect. The pronunciation is on point there.
Yeah. Can't you use here on your slide, can't you go to draw and you can write like with your mouse?
Unfortunately, I'm using that mouse on the laptop. So, but draw. Where is draw? Oh, here.
Yes.
Like using this pen.
Yes.
Okay, let's see if I can do an integral here. It's not writing. Or maybe I didn't click here. No, it's not.
Double click, say like it
Double
should,
click what?
like when you're writing, just before you write your sign,
Eh,
just try and double click and then you do it. Because it should.
yeah, if it was writing, it would be nice. Let me go and learn how to do this, and we will do it.
Yeah,
So okay,
yeah.
maybe because he's
Maybe
looking for this, what I can do for
write
now.
a document as well, a blank word, and then I think it will be also easier for you to just to draw on it and write your integrals and your equations freehand.
Is it? Let me go there, like here.
Yeah, maybe maybe it would be better. Go to draw.
Draw. Okay, there I go, and then let me see. No,
You're not clicking on the thing.
I know.
You need to
But
press
only
and hold your cursor
get
down
to
still.
learn. Yeah, I guess we'll just have to work with what you know now.
Oh, like that.
So
Yeah.
yeah,
Oh, yeah. It will need a mouse because I'm holding at the same time on this. I'm using the pad on the laptop, so it will be hectic. Let me get myself this art of writing here. In the next one, I will be perfect on that.
all
But
right.
then for now, for that person who has got a question, do you mind if I can give you my WhatsApp number and you can send me a WhatsApp and we can do it via WhatsApp so that we don't waste every other person's time? You can take down my WhatsApp number. Here it is. Please, it stays with you who are in class, and you can contact me via that WhatsApp anytime for any questions, but not questions to the assignment because I'm not here to do your assignments. Please, are you writing down my number now?
Yes, sir.
082
Yes, sir.
889
02. Yes.
082 889 6520.
520. Yes, I got it, sir.
Please just save it, and yeah, you can ask me those kind of questions offline, and we can see how we can be able to assist.
Yes.
And have a wonderful evening. Thank you so
Let me-
much.
And sir, before you go, since we taught you how to write, sir, can you be lenient with your madam that side when you are marking our assessment?
I don't.
See, Mine, we cannot teach you for nothing.
Unfortunately, ne, I don't mark. I was a marker before. I have stopped marking. I'm just a tutor now. So if I was a marker, I would be. In fact, I would know that these students are the ones that I have taught because of the way you will be writing things. So you will write things differently now. So don't stress. I think that if you have followed what I've just said here, you won't need any leniency. You will just do things properly, honestly.
Yes, sir, that's true.
Yes, I know. So I'm going to learn the art of writing on Word like this. Oh, this is brilliant. So then we can be able to now engage and do questions, and I am able to write and using different pens, and I can write my other things in my derivative like here. It's just that the handwriting will be very bad for now because I'm using the same thing. You see.
Not here for the handwriting, we're here for the maths. Don't worry.
Yes, yeah, this is rule number 2. No, I'm getting it. So you don't want to
the
you don't
slides
want to
that
see
you
the
did last year, we couldn't download them.
okay. So guys, yeah, this is it for the day. Now, so this F prime X in rule number 2 is an ice block for the drink. This is the drink. You don't drink that, you drink this. So you add 1 here, divide by the result, throw this ice away. Done. Bye-bye.
Thank you, sir. You just asked me to remind you to upload the slides before we leave.
Oh, yes. Oh, to go to the chat. Yes, let me go. How do I do that? Let me close this word. I'm not saving. And I am sending my slide to where now? To the chat here. Where is the chat? There you go. Right. And I add something. No. How did I do that the last time? Or should I go here and do that? And go there and here and here. It's not working.
Try copy paste, sir.
Copy paste. Let me go back and copy and come back here, there, here, and paste. It's not happening. Here, why don't I have, search. Why don't I have an option of that thing like that looks like a money clip for pasting? Something is not right here.
Sir, can you try
Yes,
and click on that one, the one on the first one, that first icon there?
this one.
Okay, then the third one,
Yeah,
insert
insert
link.
clip. It will be a link, but if it's a link, will you be able to get it? Because we are not on the same SharePoint.
Okay, can you click on that one on these two, sir? The
On
ones
which
on
one?
the
This one.
the last one. Down, sir.
Down. Yeah. This one.
Yes. Yeah. Think
Delivery options.
You can try searching for how you saved it and maybe see if it appears.
yeah, search there, sir. Because that's where we're gonna win.
Okay, let me say UNISA.
And if it's not showing, then write PowerPoint since you used a PowerPoint presentation, right?
Yes.
Okay, write a PowerPoint, sir.
PowerPoint.
Isn't it that one? The one
But
that
the last time it was so easy, man. Something is not happening here.
click there, sir.
Where?
Go back to that plus icon at the bottom.
This one.
Yes.
It's not responding. It's on strike. Yes.
Then power this one, the power by.
Looks like it's
Then
searching. Aye.
Last time you shared from the PowerPoint, you went to PowerPoint, then you said share.
I went to PowerPoint. How? Here. Let me see. File. Share.
Yes, then you press share.
I pressed what now?
click share with people.
It's not responding.
Can you
But
save
then
it first?
can I email should I maybe close it first and do what? Stop sharing or what did I do that time? I don't remember, man.
So I checked the link from the previous. It was a SharePoint link.
Is it?
Yeah.
So let me
UJAC SharePoint.
It says UJ.
Yeah, UJAC mysharepoint.com. So I think it was your personal SharePoint that you shared with us.
But you could open the document.
Yeah,
Me,
I
I
just opened it
couldn't
now.
open it. That's why I was asking. I couldn't open it last week.
Is it? Then the A, because we're not using, if it means that the way I shared it there, it is not. So let me just email it to Dr. Lamini and she will email it to you guys. How about that? Because with this, because I'm using my work email, laptop here, so it can only share with people that have got a UJ address. Like, so that is why you are not getting it, and I don't think we will win this way. So let me email it to Doc, and Doc will email it to you guys.
No problem, sir.
Perfect.
Are you able to
So
stop the recording?
all right. So yeah, I will respond to your WhatsApps but if you don't respond, it means I'm busy with something. I will eventually respond, even if I don't respond immediately. Bye.
Then stop the
sir.
recording.
Yeah. Come again.
You have to stop the recording.
Oh, I have to stop it.
Yes.
How?
Must,
How do I
must go
do
there
it?
on more.
More? Yes.
You stop sharing. Then you
I'm
press
not
on.
the one who started sharing. Who
But
recorded?
I think she gave you the powers today.
But she
Okay, fine.
can't because I'm not using the same thing as you. I'm not
It's
using.
fine. I'm gonna call her. I'm gonna call her to stop. It's fine.
Yeah, she must stop it because I don't have the powers. I think you guys have got more powers than me because you guys have got a domain or a UNISA domain.
No, it's okay. I'm gonna call her now.
Okay, perfect. So can I leave? But you shouldn't leave before she stops it, because if she don't stop this thing, it goes on indefinitely. Wombe vari mina.
Vari vakumufonela.
Ndiona nomboro pangeyo.
Ndandione ma.
Hey.
Rita richamanga rwambo rwacho vasaripya vantu.
Hey, vasingonyadza.
Vava kuzvipa ti?
Arali mumwe okona uri nama dzavo.
Holani auto pronounce perfect.
Gereka ituda how?
Yeah, you are a very fast learner.
Vakuzvifa. Ravya rava namupedhi apa izviva zvopera.
Ndiwa hasho.
Vakuzvibona.
Yeah. No, kalirare vana vasho.
Handizvona.
Mara holani orinderawo avala vachistop ngori ratwa rote panoni yasastopiwa entry aicha record aichawanara.
Vari rudodzura kuve napfariso hone ene.
Efariso redani.
Yona rena.
Ndivakorombi vagai.
No.
Ndifariso korombi wagai wacheni. Oh. Una vakorombi vachini. Let me call Doc, because if we this meeting, if we go, all of us we go, then there will be a problem. Let me call her. Doctor. Maybe she's in that other meeting. Yeah. Mara zvikopfarana zvibharo zvaona.
Zvikoda hone zvitovori zvikotoda uri ri ḓi ṋe tshifhinga ngori okay sa nṋe ndo rali nda tshi balelwa u attenda navho doctor ngauri vha tshi vha khou dzi ita nga masiari ndi mushumoni.
Okay.
Mara zwino I think vho kona uri humbulela zwavhuḓi nga madekwana ri nga kona u attenda. Zwi amba zwori sa next week ri nga ri tshi ṱangana vha wana uri okay huna zwe ra prepare ro go through maybe dzi example na mini. So nṋe ṋamusi vho nda ndi khou tou a thi ḓivhi mara ndi ḓo catch up with time.
Zwi dini hezwi zwithu. Hezwi zwa dina ndi vhe ndi ndo na dzi answer ni dzhena na answer mulingoni na to balelo dzi kopolola dzi ni tshi ṅwala kha hafhaḽani.
U firi dzhena na answer already.
Zwa straight ndo dzhena no fara answer vhe. Dote. Zwa vhukuma. Ina milayo yoṱhe.
Ava ri ḓo vhona ri ḓo lwa nazwo.
Mara ava tsha fara founu. Mara kha vhe wo funa po huna muthu uphiwa dzi right dziḽani ngori net kono fhiwa ngori thi shumisi domain ya vheiwe.
Zwino mashudu mavhi because na nṋe ndi khou zama hafhanoni ai kusumbedza tshithu.
Havhaḽani vha tshi ita ma meeting ho funa no volunteer vha ni ṋea powers dza u namudzela.
Huna ṅwe ya nkikha nda to vhuya.
Okay. Brenda.
Hello.
Are you winning with trying to find her? Because if we leave this meeting, she will not be able to have this recording saved, because it will still be continuing on the background.
No, if everyone leave the meeting, it's gonna automatically
stop
recording. Yeah, but
okay.
The problem, not everyone's gonna leave. Some people are not gonna leave.
Okay,
but
now
I cannot find her. She's offline.
Okay, now everybody go.
Okay, man. Okay, sir.
Okay, everybody go. I will be the last one to go. Everybody go. Go. Yeah.
Okay, sir.
Yeah. Okay. Bye. Aburukwa. Aye. Tata. Alice. Tandi. Sibiya. Go. Chabalala. Go. Khutazo. Go. Chabalala, you are still here. Alice. Tandi. Sibiya. Go. Tandi. You are the only one left. Ash. Hey, Doc, you are still in another meeting. I wanted you to stop recording. There is one person who has not left. I was told that if there is somebody who is still in there, the thing will continue, it will not stop. No, we are done. There is one person, Alice Tandisibia, is the only one who is left. And I'm afraid if I leave her here, the recording will not stop. Can you stop the recording then? And then I can leave. I can't. I don't have those powers, remember? Yeah, but I don't have to where do I go? To people, yes. Next to people. Okay, but next to participants. Yeah, it says disable only. It's not saying that I can disable camera and mic. Okay. Yeah, I have gone to the person. Oh, remove from meeting. Ah, yes, I see. Yeah, let me remove. Ah, gone. Then I'm leaving as well.